All right, so today we're going to be talking about Chapter 4, Lesson 5. This is the second half. It's all about computing with scientific notation, specifically addition and subtraction. So when we start talking about using scientific notation to add and subtract, we have to make sure, and this is super important, we have to make sure that we can line up the decimals. Recall from last chapter, if I did 3.1 plus 4.82, the decimal points have to line up. So this would be 3.1, 4.82, and I have to fill in that missing space with a 0. Now, with scientific notation, we have to do the exact same thing. However, what's very important, it's a Y. The powers of 10 have to be the same. The reason why is because the powers of 10 really tell us how many place values we have to move our decimal point. And if they're not the same, that means our decimal point isn't in the same location where it should be. So when we move it, we have to make sure that we are very careful. So if our exponent increases, and this is a difficult and confusing concept, exponent increases, number out front decreases. The reason why is because if we want to stay balanced, if this goes up, this has to go down. And how we change this to go up and down is we move the decimal point. So if we make this bigger, we have to make this number smaller. Same thing happens if we go in the opposite direction. So if the exponent decreases, the number out front has to increase. So I'll show you some examples on both addition and subtraction. Otherwise, once we make the powers of 10 the same, then it is simply adding the numbers or subtracting the numbers, making sure the decimal points are in the same place. So, for example 1, I have an exponent of 5 and an exponent of 6. I want to get my exponents to be the larger of the two, so I want to keep the 6. Because right now this is the bigger number, which means that this is going to be driving a lot of the information. This is the smaller number. So I want to take this 5 and get it to a 6. So if I increase the 5 by 1, I get to 6. And I need to make this smaller. I increase by 1 here, so I need to decrease by 1 place here. So this is going to be 0.73. Now, I'm going to take these two numbers out front and add them together. So I'm going to do the 2.4 and the 0.73, add them together. I have an empty space here, so I'm going to add a 0. 3 plus 0 is 3. 7 plus 4 is 11. Carry the 1. 1 and 0 is 0. Plus 2 is 3. So now I have 3.13. And then I add back the place value, or the power of 10. So I have 3.13 times 10 to the 6th. Something you could also do, this takes significantly longer and it's a lot more steps. Change each number to standard form. So this number here, I would move the decimal point 5 places to the right. So that would be 7300000. And then 2.4 times 10 to the 6th would be 2400000. And I can add them together now. Oh, too many zeros. There we go. Let's just start over here. So 7300000 and 1, 2, 3, 4, 5, a 4, and a 3. So I can add them together. Add vertically, so zeros all the way across. 3, 7, and 4 is 1. Carry the 1. This is a 2. 1 plus 2 is 3. So I still have the 3, 1, 3, which is what I was hoping for. And then I have to move the decimal point 1, 2, 3, 4, 5, 6. So I still will get 3.13 times 10 to the 6th. It just takes longer to get there. Let's do another example, example 2. Now, this one has an exponent of 7. This one is only 5. So this is the number that I want to keep. This is the number that's going to be driving everything. So 1.7 times 10 to the 7th, I'm going to keep that. I want this to change to 10 to the 7th also. So from 5 to 7, I have to increase it by 2, which means I have to decrease this by 2 places. So I'm going to move 1 place and 2 places. I have an open space here. And now I have my 2 numbers that I'm going to be adding together. Next step is to simply add the numbers out front, line up the decimals, so 1.7 and 0.0625. A lot of empty space here, so 0, 0, and 0. 5, 2, 6, 7, 1. And then bring the power of 10 back down, so 1.7625 times 10 to the 7th. Again, something you can do is change each of those to standard form again. So this would be 1, and then 1, 2, 3, 4, 5, 6, 7. And that would be what it would come out to be if we changed them all to standard form. We would get the same answer. Again, it's just one extra step that we have to go through. All right, so that's addition. Let's talk about subtraction. The good thing is it's exactly the same process. The only difference is we're subtracting now instead of adding. So here we have a number that's in standard form. I want to get this to scientific notation. So that'd be 6.45 times 10 to the, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 8.27 times 10 to the 7th. This number here has the larger exponent. This is driving the problem, so I'm going to leave this one alone. This number has the smaller exponent, so I need to change them so they're in the same exponents. So this I want to have times power of 9. I increase the 7 by 2 to get to 9, so I have to decrease this number by 2 places. So it would be 0.0827. So I moved it 1 and 2 places, making this number a smaller version. And now I line up the numbers, so 6.45 and 0.0827. Fill in the missing spaces with zeros. And now here's what needs to happen. 4, we have to borrow all the way across because I can't take 7 away from 0. But I can take 7 away from 10. So that's 3. 9 minus 2 is 7. 14 minus 8 is 6. 3 minus 0 is 3. And 6 minus 0 is 6. So this would be 6.3673 times 10 to the 9th. Again, you can still change it to standard form. I would suggest against it, though. Example 4. This one's going to be a little bit more interesting because now this number is my larger number because negatives were kind of opposite. So negative 5 is closer to 0 than negative 7. It's farther to the right on a number line. So negative 5 is larger than negative 7. So this is the number that is going to be driving the problem. So this is the number that I want to keep. Minus. I want this one to have a power of negative 5. So I have to increase this by 2 to get to negative 5. So I have to decrease 4.9 by 2 places. So 1, 2. And the reason why I can do that is because if I increase the power by 1, I'm really multiplying by another 10. So in order to multiply by 10 here and keep everything balanced, I have to divide by 10 here. And when I divide by 10, I can simply move the decimal point 1 place to the left. That's very important. Now my powers of 10 are the same. So I'm going to take my two numbers and line them up. I have an empty space, so I'm going to fill it with a 0. And I'm going to start borrowing. 10 minus 9 is 1. 10 minus 4 is 6. 1 minus 0 is 1. And 3 minus 0 is 3. Bring down the decimal point. So this is 3.161 times 10 to the negative fifth. If you go to the smaller of the two exponents, it will still work. But then you will have to convert it back. It takes an extra step in order to do that. So that's why I like always going to the larger of the two exponents, because it's one less step to deal with. All right, so that is the end of this second section. If you have any questions, please let me know.